In this video, we are going to go through the explanations of the entire harder second module of Bluebook 10's math section. And you can see I'm on the Bluebook app and I can just resume if I've properly stopped the exam using the tools within it. So once I come back in here, I just hit close and I already have the exam up and ready to go. And remember that while we've got our scratch pad on the right hand side, we're going to try to do as much as we can within the interface and not have to engage that scratch work. So our little tools are going to allow us to do some highlighting and eliminating, and so we're going to use them liberally as well. And I probably would just have the calculator kind of down here a little bit so that I can start engaging with it as soon as I need to. So we'll begin with number one. We always skip to the end, figure out what we're being asked for first. And in this case, we want to know what type of function best models the relationship between the descending airplane's altitude and time. So we should be able to just kind of focus on that aspect of it. And you can highlight it just with your cursor if you're so inclined. And we then read that an airplane descends from an altitude of 9,500 feet to 5,000 feet at a constant rate of 400 feet per minute. Well, it's certainly not increasing. So goodbye to C and D immediately. Then we've got to consider whether this is an exponential increase or a linear decrease. And exponential decrease or linear decrease, that is. And we should recognize that in this case, we are engaging with something that's moving down at a constant of 400 feet per minute. So our correct answer is going to be B, and we should be able to move to the next problem almost immediately. We'll then again just kind of square things up on the left-hand side, and once more we can see that there's this question asking what is the slope of line J. So we'll just, again, kind of highlight that for our reference using the cursor. And we read line K is defined by y equals 17/7 x plus 4. Line J is parallel to line K in the xy plane. And we should know by definition that parallel lines have identical slopes. So we'll select choice B, and we shouldn't really even need to engage with our elimination tools for number 2 before we click next. Again, just kind of framing this up since we've got the scratch board on the right for reference if we need it. We will once again skip to the end, and we're being asked which statement is the best interpretation of the y-intercept of the graph in the xy plane in this context. And we see we've got Caleb used juice to make popsicles. We have this function f of x, which stands in for y, and that is equal to negative 5x plus 30. So we should know already that the 30 has to be the y-intercept just because this is in the slope form or slope-intercept form of a line equation. So that allows us to eliminate both A and B. Then we've got to continue reading. It approximates the volume in fluid ounces of juice Caleb had remaining after making X popsicles. So we've got to think about what that plus 30 means. Well, at X popsicles being 0, he has 30 fluid ounces. So that means it's what he has when he began to make the popsicles. It is not how much he used for each popsicle. We can eliminate choice D, we select C, and we move on to the next problem. Again, I'm just going to frame this up a little bit, but you can see we haven't really had to engage with our scratch work or the calculator at any point yet in this section. So once more, number 4, we're going to skip to the end, figure out what we're being asked for. We've got which of the following is the best interpretation of the vertex of the graph of the equation in the xy plane. Well, here's the first time we could potentially use our Desmos calculator here on the left-hand side. So if we've got this physics class that's planning an experiment about a toy rocket, the equation is going to be y equals negative 16 times x minus 5.6, and that's going to be squared, plus 502. And I am going to have to use my zoom to see what's happening with that vertex. And I can just kind of come over here. Oh, there's my vertex. It's way up here, but I should be able to recognize at this point that that vertex is going to be the height at some point. So it's the maximum height. And when does that maximum height occur? Well, if we were to scroll back down here, we can zoom in a bit and see that it's got to be halfway between that 11.2 and 0. So that means it's got to be the 5.6 seconds. And so choice B, this toy rocket reaches an estimated maximum height of 502 feet, 5.6 seconds after it is launched into the air. If you just recognize it upon reading, that's absolutely fine, but you can definitely use your little Desmos calculator to prove out that situation just by, making sure that you grab onto it and figure out that there's my 5.6, 502. I could have even just clicked on the vertex itself. So there's our correct answer for number 4. We'll move on to the next problem, and we'll just X that thing out as well. Here is our first student-produced response question, and here you've got the instructions for those kinds of questions. I really, again, want to do this within the calculator as best I can. I'm going to drag the little keypad down here, and we are being asked for the value of f of 10. So in this case, we're told that the f of 5 is equal to 32. So that means that 32 is going to be equal to 4x plus kx, or sorry, f of 5. So it's going to be 32 is going to be equal to 4 times 5 plus k times 5 minus 1, which of course is going to be 4. And I can just write in my notes about the solving right here to get to the right answer without, again, having to go to the scratch work. So I should be able to recognize now that 4 times 5 is 20, 32 minus 20 is going to be 12, so 12 is going to be equal to 4k, because 5 minus 1, of course, is going to be 4 and 4k. So that means that in this situation, my k is actually going to be equal to 3. So I'm just going to keep track of that in my little structure here, that k is equal to 3, the way this is set up. And so then I know that I'm being asked for the f of 10. So that means I just plug in 10 when k is equal to 3. I'm going to just close these out for ease of use. But we've got 40 plus 3 times, well, that's 9. And that's going to be equal to 67. And there's my answer, because we know that k now was 3. And we've got our solution. We'll just put 67 right in there and move on to the next question. Here we've got another problem asking about geometry, and we don't want to engage with the information geometrically by like drawing this thing. I just want to track the information as carefully as possible, and again, I can even take notes in the little Desmos calculator as needed. But I'm being asked for the measure of angle f. And it says triangles ABC and DEF are congruent, where A corresponds to D and B and E are right angles. So I'm just going to write here for my reference, A is equal to 18 is equal to D. So that is just telling me the first one. And then I know that B and E are right angles. So that means that my angle C that's going to correspond to F is going to be equal to 180 minus the 18 minus the 94, the two right angles, and we've got a correct answer of 72. Again, not even engaging with the scratch work through question 6. So on to the next problem. We've got this guy, and once more we have a great opportunity to use Desmos. So if we've got these two inequalities, we're trying to find a solution in the xy plane. So we know that y is going to be less than or equal to x plus 7 is one of the inequalities. And then we've got y is greater than or equal to negative 2x minus 1 is going to be the other of the two inequalities. And I should recognize at this point that I'm a bit higher than I need to be, so we'll zoom in a bit more. And I'm going to just make this a little bit bigger on my screen here. Well, it doesn't want to make it a little bit bigger, but it'll be fine for the purposes of what we're looking at. So I'm just trying to find something that's going to be in the overlap of these two pieces. And we should recognize that the negative 2x plus 7 is going to be the light green, then the negative 2x minus 1 is going to be the light green up here, and then the blue is going to be this x plus 7 inequality. So I need something that is in that range there. And so let me, and I should be able to. Well, calculator is going to be the size that it is, which is absolutely fine. I can still zoom in. And whoops. So if I'm just looking at my answer choices, I can use the tool here. And I should recognize that -5 is over here. So -5 is down here. And so if we're looking at -14, 0, well, that's going to be way over to the left. And that's not in our kind of turquoisey overlapping blue and green color. If we do 0 and -14, so 0, -14 is going to be just in blue, not this overlapping tealish color. So that's going to be out. And then we've got 0, 14. Well, that seems to be very much within the range here. And then 14, or actually, sorry, 0, 14 is going to be outside the range. And you got to be careful about that because I went with the x value first, and 0, 14 is just going to be in the green area up here. But 14, 0 is certainly going to be in the range, and you can even put it into the Desmos and see where that point is. Right there is definitely going to satisfy both inequalities in the two structures. Of course, you could also plug this in to solve, but I would be of the opinion, notwithstanding my inability to try to make this thing bigger with the calculator, the Desmos is probably a little bit faster. So our correct answer here for number 7 is going to be D, and we move on to the next problem. And so here we've got a question asking just what must be true. So when I see a question such as this, that should indicate to me I need to logically evaluate, not fully calculate. So I've got these distributions, and I should just kind of look at them big picture. I can see that they've got the same values, and they're equitable, right? So on the far left to the far right, there's like the same symmetry occurring with the distributions. So we'll just consider statement 1 first. It says the median of dataset A is equal to the median of dataset B. Well, the way that we solve for a median is we need to determine the number of terms, and then we've just got to count up to whatever the single middle term is. If it is an odd number of terms, if it's an even number of terms, it's going to be the average of the two middle terms. So let's just count the number of terms in A. So we've got 1 plus 4 is 5, 5 plus 2 is 7, 7 plus 3 is 10, 10 plus 2 is 12, 12 plus 4 is 16, 16 plus 1 is 17. So that means that the 8th term in the sequence is going to be our median, because you're going to have, if we're talking about 7, actually it's going to be the 9th term, because you'll have 8 before 9 and then 8 after 9 in a set of 17. So we're just going to count 1, then that's going to be 5, 6, 7, 8. The 9th, the median, is going to be 13 here for data set A. And we're just going to count the number of terms for data set B, 2, 4, 6, 7, 9, 13, 15 here. And so when we've got that set up, 2, 6, 8, 9, 11. Oh, sorry, I think I miscounted. 11, 15, and 17. So it's the same number of terms. And we should recognize that, again, the 9th is going to be the median. So 2, 6, 8, 9, it's the same 13. So we know that Roman numeral 1 is certainly true. So we can eliminate choices B and D as not matching the fact that the median of the two sets is going to be equal. Now we've got to consider the second, which says the standard deviation of set A is equal to the standard deviation of set B. All we need to know is conceptually how standard deviation works. Standard deviation measures the distance of terms from the average or mean. And we should be able to see, because of the symmetry, the mean is going to be the center of the set of values, which is going to be 13 again. I don't want to fully calculate it. I just want to understand it logically, because we're just being asked what must be true, and we can trust any data interpretation figures for the SAT as drawn to scale. We can just trust it. So that means we're trying to say that the distances from data set A are the same as the distances in data set B, and we should recognize almost immediately that there's actually more of a distribution out in data set B, because we've got two terms that are at the extreme edges of the range 10 and 16 in dataset B, whereas, and those came from the average basically of data set A. So data set A has more terms at the average, data set B has more terms at the extremes. So that means that the standard deviation is not going to be equal for the two sets. So that allows us to eliminate choice C. And at this point, we'd probably select choice A and move on to the next problem. Here, we skip to the end. Once again, we are being asked for the value of R. So in this case, we're probably going to want to bring back in our old calculator, handily scoots things over just a little bit, but I need to see everything. And we'll just clear out all of our stuff from the prior problem. It says a scientist initially measures 12,000 bacteria in a growth medium. Wonderful. 4 hours later, the scientist measures 24,000 bacteria. So we're assuming exponential growth. The formula P equals C times 2 to the RT gives the number of bacteria in the growth medium, where R and C are constants, and P is the number of bacteria T hours after the initial measurement. So this is probably the first time I'm going to advocate writing out the information, because I'm going to have to track like two different equations. So we'll engage our scratch work, and we know that to start, P is equal to 12,000 when T is equal to 0. So we can set up the equation as 12,000 is equal to C times 2 times R times 0. And I should recognize that when I do R times 0, no matter what R is, I get 0. So that tells me that I'm going to have 2 to the 0 power, which is going to give me 1, because anything to the 0 power gives us just 1. So that means that C is known to be 12,000. So we got one piece of this already. And I'm just going to kind of box that off for clear reference. Then we've got to deal with the 24,000 bacteria. So we know that when we have P is equal to 24,000, that we're going to have an equation of 12,000 as our new stand-in for C times 2 times R times 4. So now I've got 2 to the 4th, and I should recognize that R here has to make it so that it's just 2 to the 1st. So that means that R times 4, or 4R, has to be equal to 1, which means that R is going to be equal to 1/4. And there's our correct answer of B. And you will have to engage with your scratch pad, but we went as long as we possibly could without doing so. Then we'll click our next question. And here we have a problem that we just have to be careful with. So we're being asked for the surface area in square units of the cube. So I am probably going to want to use my calculator here. Oops. And I'll need to, whoops, come back here, fella. We're going to need to see the expressions down there. There we go. So we've got a cube that has a volume of 474,552 cubic units. If you don't remember volumes for cubes, you can hit this reference button and you'll see that volume is just going to be length times width times height. So as far as a cube goes, since it's got all the same edge lengths, we're just looking at the volume is that cubed. So what I need to do here is I'm going to have to take that 474,552 and we're going to have to raise it to the 1/3 power, because that's what the cube root is, and that's probably the easiest way to write it in to the Desmos structure. So we now know that each side is going to be just 78 for the, or each edge is just going to be 78 for this cube. So now surface area is just going to be 6 times the area of each side. So we're going to take our 78 and we're going to square it. We get 6084. And then we've got to take that 6084 that we just saw, 6084, multiply that by the 6 sides of a cube, and we get our correct answer of 36504. So just be careful, again, probably using the Desmos calculator, and you should be able to make quick work of number 10 here. So we'll go ahead and hit next now. And in this case, we've got a question asking for a very specific combined value of 8x plus 7y. And that should indicate to me that we're dealing with a clever system of equations. So what we have happening here, we know that 2 times 8x plus 4 times 7y is equal to 12. And then we've got negative 2 times 8x plus 4 times 7y is going to be equal to another 12. And hopefully, I recognize that I could solve for 8x plus 7y pretty immediately by just adding these two equations to each other. Because when I do that, what ends up happening is the 8x's are going to go away. So now we know that the 8x's are gone, and we've got 4 times 7y plus 4 times 7y leaves us with 8 times 7y, which is going to be equal to 12 plus 12, which is 24, which means that when we divide this whole thing by 3, or sorry, not by 3, by 8, 7y is going to be equal to 3. So now that we have 7y is equal to 3, we can just plug that into one of our prior equations and solve for 8x. I'm not trying to solve for x and y individually, though, because that's just going to be an unnecessary waste of time. So we've got 2 times 8x plus 4 times 7y, which we now know is 3. So that's going to be plus 12 is equal to 12. Well, now I just subtract 12 from both sides, and I go, well, now 2 times 8x is equal to 0, which means that 8x is equal to 0, so our sum of 8x plus 7y is just going to be 3. We hit 3, and we should recognize that because the 2 times 8x and the negative 2 times 8x, when they change values, you still have the same outcome. That basically the only thing that's possible is 0. But to prove it out, you can just use your scratch pad and work through the algebra. Moving on to the next question and the beginning of the second half of this section that we're doing at time and a half pacing, just so I've got more time to kind of explain things as we're working through the problems. So just kind of clearing out everything, we are being asked for the area in square yards of this town. So I'm going to just do that highlighting thing that we do. And there's really going to be two ways that we can work through this. The first is probably the more technically sound way. So I know that since 1 mile is equal to 1,760 yards, I know that 1 mile squared is going to be equal to 1,760 times 1,760. And if we use the old calculator here, 1,760 times 1,760 gives me 309,7600. So 309,7600. And I should look at my answer choices right now and recognize that the certain town has an area of 4.36 square miles. Well, if 1 square mile is going to be equal to 309,7600 yards squared, well, I don't even need to do the full calculation. It has to be choice D. And you want to look for those kinds of efficiencies throughout the exam. Now, let's say that you forgot the rule about squaring for this sort of thing. You can also manage this by using a little just kind of drawing to model it. So we'll just thicken this up a little bit and go with a nice little brownish color there. And so taking a look at this, we know that we've got 4.36 square miles. I just have to do my conversions at the single dimension. So this is going to be 4.36 miles in linear miles, and then this over here is just going to be 1 mile. So 1 mile is going to be 1,760 yards squared. And I could just use the calculator once more to come over here and say, well, let's do 4.36 times 1760. And there's my 73.6. So that's going to be equal to 7673.6 yards squared. And then it's just a matter of actually taking that 7673.6, multiplying it by my 1760 one more time, and that shouldn't be yard squared. That's just an individual yard, of course, up here now. and we multiply that by our 1760, and there's my 13,505,536 as well. So one of the skills that you want to encourage most on this exam is flexibility in approach. So think about how you could potentially do problems such as number 12 in multiple ways so that you'll be able to perform better on test day by just choosing whatever's most apparent to you as the approach moving through the problem. So number 13, here we are being asked for the measure of angle n. So I don't know what that means, but I know I'm going to have to do something with geometry. So if I have actual geometric coordinates, I'm more inclined to draw. So we're going to just grab a little line here, and we should recognize that all of our coordinates seem to be positive for the x and positive for the y. So that's going to allow us to have just a little bit of like pretty much just one style of or one quadrant that we need to work through. We don't need to go through all of the quadrants. And just thicken this thing out a hair for myself. There we go. And so then we'll just have this guy down here, make sure it's straight. So we've got quadrant 1, and we can see we've got triangles PQR and LMN are graphed in the XY plane. And on your scratch pad, you're probably not going to have markings, so I'm going to have to indicate that we can just do this. 1, 2, 3, 4, 5, 6. That sixth one was kind of wild. 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. Good enough. And then we'll do the same thing over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll even go to 10 on this one. So now we can just plot the points, and we know that P, Q, and R are at 4 and then 5. So that's going to be point P. We're going to have 4 comma 7, which is right here, and that's going to be point Q. And then we've got 6 comma 5, and that's going to be point R. Simple enough. And then we've got LMN, and it's just adding to the points that we already have. So L is the same spot as P, it's 4, 5. And then when we do 4, 7 plus K, well, that's just going to be over here. So that, because no matter what K is, we're just extending on the horizontal line. So that means that over here is going to be M, and then up top, we're extending on the vertical line by having 6 plus K. So we keep our X coordinate at 5, and so it was 6 and, oh, I think I actually did the other way around. So M is 4, 4 plus 7K is going to be M up here. So we'll actually grab you and we'll dump you up here. And then the N is going to be the 6 plus K. So that's going to be 6. And we add our K over here, and it's still going to be down like here is going to be N. And we should recognize that whether we're looking at this triangle here or this longer triangle now here, we end up with the exact same angles because we haven't changed that right angle at the vertex P or L for that matter. So now we've just got to continue to work through what's happening in the problem. So it says the measure of angle Q is T. So that means that this angle measurement is T. This angle measurement then also has to be T. We already know this is a right angle. So if we're trying to find the measure n plus t plus 90 has to be equal to 180 because that's just the total number of degrees in a triangle. So that means that our n is going to be equal to, well, 180 minus 90 is 90, and then we've got our 90 minus t, and that matches choice C. And while I could do some modeling here, because they're not hiding the math, I probably just want to start engaging with the geometry and seeing what happens. But there's our correct answer for number 13. We're on to the next problem. So once more, we've got a little bit more of a convoluted structure as we get into the teens of the section. And we're going to skip to the end, figure out what we're being asked for first. And in this case, we're looking for the maximum number of large candles the owner can purchase to stay within the budget. And since I'm already engaging with our scratch work, I'm going to just put max L number equals question mark, so I don't forget what I'm being asked for. So we know that the budget at the top here is going to be equal to $2,200. And the owner must purchase a minimum of 200 candles to maintain the discounted pricing. Okay, so if we're calling L the large candles, we know that L plus the small candles has to be greater than 200. And we know the owner pays $4.90 per candle to purchase small candles and $11.60 per candle to purchase large candles. Okay, so that means that 4.9s plus the 1160 or 11.6 L has to be less than that $2,200. So we've got this structure here, and we want to make it so that we are getting the maximum number uh, of large candles. So we need to think about how we can possibly do that with the information that's been presented. So we know that regardless of how the L plus S is going to work, that there's got to be this range of the two things. And if I'm trying to get to a common multiple, I basically need to just set it so that my L plus S is going to have the same coefficient for the 4.9s to get rid of the 4.9s, because then I can just add the inequalities and basically cancel things out. So we're going to just multiply this by 4.9s. Well, not 4.9s, 4.9. So I want to make sure that my inequalities are facing the same direction. So we've got less than 4.9s plus, slide over a little bit, give me a little more room, 4.9L has to be still greater than, and I'm going to just use my calculator over here, 4.9 times 200. Oops, not equals 200, which gives me 980. So now I can add inequalities the exact same way I would add equations. So I'm going to keep on the left-hand side. We're going to have 4.9s plus 11.6L plus 980. I'm going to have to zoom out just a little bit over here to get all of this in. Oh, zoom out just a bit. There we go. Well, maybe not that much. There we go. That should give me enough room. So now we're going to have less than 4.9s plus 4.9L, and then we've still got to have our 2200. So now we should recognize the 4.9s's, we can just subtract them out, cancel it immediately. Now I'm going to subtract 980 from both sides. We're going to subtract 4.9L from both sides. And so if I just use the calculator for 4.9, I really should be able to do that. That's going to be 6.6, and that's going to be 6.7. Let's just make sure. Don't want to make any errors. Model good behavior, right? So minus our 4.9 is indeed 6.7L. Has to be less than, well, the 4.9Ls cancel out over here, and 2200 minus 980. So again, we can just clear that out. 2200 minus 980 gives me 1220. And we'll take that 1220 and we will divide, whoops, nope. And we'll take that 1220 and divide it by 6.7. And that gives me exactly 182.08. So we know L has to be less than 182-ish, which means that the maximum has to be 182 as the correct answer for number 14. And you can see you just treat the inequalities kind of similarly to how you would treat them as equations, and avoid multiplying by negatives because it's just going to make things harder. So we move on to the next question, and we've got a square inside of a circle. So taking a look at what we're being asked for here, we want to know the side length in inches of the square. So excuse me, there are instances where I may have to draw something. And those instances are when we have overlapping shapes and we know the real numbers for scale. So in this case, a square is inscribed in a circle means the square is going to be in the circle. So we're going to go with a circle first, and then we're going to put a square in the middle. That seems good enough. And I should recognize that I want to relate the square to the circle, and the radius is not going to do that. Instead, I need to make sure that I'm getting a diameter. And we know that a diameter is exactly double a radius. So this diameter is now 20 root 2. And hopefully I recognize this as a 45, 45, 90 right triangle with a constant ratio of a, and a radical 2, which means that this is my a radical 2 side, and that means that my a side is just going to be divide out the radical 2's, and we know that a is going to be equal to 20, and there's our correct answer. So there are some geometry shortcuts, such as the special right triangles. Do try to commit them to memory as part of your study. So moving on from question 15, we've got number 16 here, and this again is a Desmos special. So if I am so inclined, I can put all of this into Desmos and I will figure out the right answer. But I do need to remember the formula for a circle in the coordinate plane is x minus h squared plus y minus k squared is equal to the radius squared. So I want to intersect the y-axis at exactly 1 point. Well, that means it's got to be a radius of 4, and I've got to be touching the y-axis once. And just for really the interest of time on this video, that means that it's got to be one of these answer choices with the minus 4. So we can eliminate choice A, we can eliminate choice D. But now let's just plug in the answer choices. So B is going to be x minus 8 squared plus y minus 4 squared is equal to 16. And if I zoom, oops, I forgot my squared there. There's my circle. And I can see that I'm actually, with choice B, touching the y-axis at 1 point. On the exam, I'd go ahead and pick C right now, but if I flip it around, x minus 4 squared, and then we've got y minus 9 squared, well, that touches the y-axis at exactly 1 point, and our correct answer is C. Again, a little bit of a hybrid using the calculator that's provided and just some knowledge about circles in the coordinate plane can make quick work of that problem. Then we've got another question that is asking more about theoretical algebra than actual algebra. So we're being asked for what could be the second equation in the system. So one of the equations in a system of two linear equations is given. The system has no solution. So when a system has no solution, that means that you've got parallel lines in the coordinate plane. So we could honestly just use the Desmos calculator. You can also rearrange it in the scratch work to find which ones are parallel, but I'm probably of the opinion that this is going to be the easiest way. So I should recognize that it's got to be something where it's a 6x. So I'm leaning towards A and B. So let's just see what happens with choice A. So if we did negative 6x plus y is equal to 18, well, now I got a negative 6x plus y is equal to 18. Well, that's the same line. I can see it went right over, and that's y equals, that's not going to be no solutions, that's infinite solutions. So that's out, and it probably tells me what our right answer is going to be, because if we do 22, I can see I've got a parallel line now, and our correct answer is B, and I don't really have to do anything more for question 17. And remember, maximizing efficiency certainly of paramount importance on this test, because then we see something like number 18. And number 18 here, we've got to think about how to deal with this algebraically as efficiently as possible. So we've got these expressions. I'm not going to want to model it. It's just going to take too long. But I'm going to write out y plus 12 over x minus 8 is equal to, and I know, or not equal to, plus our y times x minus 8. And I should be recognizing at this point there's a lot of x minus 8s. So let's see what we can do to factor out common terms. So looking on the denominator, I should see that there's a y in both of them. So we could factor out a y. There's also an x in both of the terms, so we could factor out an x. And when we do that, what's left behind is x minus 8. And at this point, I should recognize that I really can then just cancel out the x minus 8s on the right-hand side here, because they're going to be the exact same factor. And then it's a matter of doing a little bit of adding with a common denominator using the bow tie. So we're going to end up with x, y, I'll give myself a little bit more room here, times x minus 8 as the denominator. And up top, we're going to have xy squared plus 12xy plus xy minus 8y. So now I want to go to the answer choices, seeking something that would match this. Choice A is way too convoluted to get to a 64xy. I'm like, I don't know where that would come from. If we're looking at choice B, well, again, I don't know where I'd be getting just a plain 12 either, so we can eliminate choice B as well. Choice C, I need to see how this is going to reduce. So if we look at choice C, I should notice I can pull an xy out, or a y out of each term in the numerator. So if we pulled a y out of each term in the numerator, we would have y times xy, and then we'd have plus 13x minus 8. And I should see that I could basically pull out y's from our numerator up top as well that we just saw. And underneath, we can actually pull a y out as well. And when we pull out the y here, we're going to end up with our x and then minus my 8y. And I go, oh, well, or sorry, my x minus 8. And there's going to be how all of my cancellations are going to work out, because the y's would cancel in the one we just worked through. The x's are going to cancel down a bunch. I shouldn't have to do all of the math. It's about recognition at this point in the section, because we know we are in the higher level difficulty problems, but we should be able to note just kind of enough which is going to be equivalent without having to necessarily do all the work. Moving on to question 19 next. So looking at number 19 here, we're being asked for which is equal to Q, and there are certainly two possible approaches with this problem. You could manually manipulate this by basically multiplying everything by 1/20th and then solving, but let's pretend we're not as comfortable with that approach. Instead, well, let's just set easy values and we can model this quite nicely. So let's just say Q, we'll pick the largest factor of 20 that isn't 20. We'll say Q is 10, R is going to be, or actually we'll do it the other way around because we want the bigger values. So we'll go with Q is equal to 2, we'll make R equal to 10, and we'll make S equal to 5. So now we know that 20 over P is going to be equal to 10 minus, we're going to have 20 over R is going to be 2, and then we've got minus 20 over 5, which is going to be 4, which is going to give me exactly 10 minus 2 is 8, 8 minus 4 is 4, so that means that P also has to be equal to 5. So we're just looking for a situation where when we've got R is equal to 10, S is equal to 5, and P is equal to 5, that we get our answer of Q is equal to 2. So looking at our answer choices, I should know it can't possibly be A because that's going to be too big. Can't possibly be B because that's going to be even bigger. I'm going to bring in my calculator for a moment just so that we can see it, but PRS in our model is going to be 5 times 10 is 50 times 5 is 250, and then we're going to divide by PR, which is going to be 15, plus PS, which is going to be, or sorry, PR is not going to be 15. We're going to write these out so that I don't make any mistakes here, but we're going to say PR for choice C is going to be equal to 50. We're going to have PS for choice C is going to be equal to 25. And then we're going to have RS, which is going to be equal to 50. and that's going to be equal to 125. And of course, 250 divided by 125 is exactly the 2 that we sought, so we'd select C at this point. And I should recognize that once we go to choice D, 20 times P is going to be 100, 20 times R is going to be 200. I'm already over, so I don't need to actually fully solve choice D, and that's a great alternative way to work through number 19 when time is getting tight. Now, number 20 here, we are being asked for the least possible k. So we know what we're being asked for. I'm going to write it out for a clear reference. Least k equals question mark. Box that off so we don't lose sight of it on our scratch work. And we should immediately write out the expression. So we've got x times kx minus 56 is equal to negative 16. And we know this is supposed to have no real solution. So we're going to have to do the quadraticing. So we're going to end up with kx squared minus 56x, plus 16 is going to be equal to 0. And I need to remember something called the discriminant. So the discriminant is going to be the value that dictates the number of solutions for a quadratic. And we know the discriminant is going to be b squared minus 4ac. And for there to be no real solutions, this b squared minus 4ac has to be less than 0, because then we'd be taking the square root of a negative, and that's not allowed according to math, at least as far as the digital SAT is concerned, unless we're talking about imaginary numbers and that sort of thing. So again, that's the no real solution part. So now we're going to plug in the values that we have, plug the values we have for this problem into this equation, or this inequality rather. So we've got 56, well, negative 56 squared minus 4 times k, and then times 16. And that's supposed to be less than 0. So we'll use the calculator over here. We're going to have our 56 squared is going to be 3136. 3136 minus 64k has to be less than 0. So now we'll just add 64k to both sides, add 64k to both sides. We've got 3136. It's going to be less than 64k. And then we'll take that 3136, divide by 60. Whoops, nope. 3136 divide by 64 gives me 49. So 49 is less than k, so that means the least possible value of k is going to be 50, and you do have to know how the discriminant works for a problem such as this. Moving on to our penultimate question of the section, we've got another little algebraic structure, and I really do at this point probably need to focus on this algebraically. So what we're going to set up here, we want to know which of these follows, which of the following points lie on the graph of each equation in the xy plane for the given system. And I should recognize immediately that 2x plus 3y equals 7 is the exact same as 10x plus 15y equals 35. So I really only need to find an answer choice that's going to allow my x to equal the y, and I'm going to, and you'll note we get our 5-minute warning at this point, that we'll deal with the easier of the two equations. So 2x plus 3y equals 7 is probably the easier of the two equations to work through. Now I just go to the answer choices and I go, well, the 7 and the 35 are ultimately immaterial to our x and y values. So I should be able to eliminate choice A and not really consider it. Then I'm looking to the answer choices C and D and looking for what I can plug in most readily to see which has the proper relationship. So I can see in 2 of the answer choices, x is equal to r. So if x equals r, let's just see what happens. So we'd have 2r plus 3y is equal to 7. So that means that 3y would be equal to 7 minus 2r, and y would be equal to 7/3 minus 2r over 3. So that would be the situation if x is equal to r. So we've got to make sure that our answer choices, one of them has to properly match that if it's going to be the correct answer, and r is supposed to be our value for x. So if we're looking at choice C, we've got 2r plus 3, or sorry, 2r over 3, but it's a positive, not a negative. And 7/3 is being added to it, so C is just a misconstrual of the algebra. Then choice D, we've got negative 3r over 2. Yeah, it's negative 2r over 3. So again, a misarticulation of the algebra. But just to prove it out with the correct choice B, if we set this up and said r is equal to y, well, now we've got 2x plus 3r is equal to 7. So now we'd have 2x is equal to 7 minus 3r, and x would be equal to 7 halves minus 3r over 2. And that's the exact structure of choice B, leaving it as our correct answer. Moving on to the last problem of the set. We skip to the end, of course, and we're looking for which function gives the total cost for the hours of repair. We just start taking notes immediately. And in this case, we learned that the window repair specialist charges $220 for the first 2 hours of repair. So $220 for first 2 hours. Then we know plus X for, well, X is going to be the hourly repair, sorry. So plus, we'll call it H per hour after the second. So then the total cost for 5 hours of repair is $400. Okay, so we know that if we've got 400 is going to be equal to 220 plus 3x, where x is the, 3h, because h is going to apply to 3 hours. If we're talking about 5 hours in total, we subtract out the first two. So that means that 180 is equal to 3h, which means that 60 is equal to my hourly rate after the second. So with that in mind, if we're talking about the dollars for repair, I've got to be careful here. So the easiest thing is, let's just say if X were equal to, oh, I don't know, instead of 5 hours, let's go with 4 hours. Well, then the cost should be equal to 220 plus 120, which is going to be 340. So if we go to our answer choices, we should get an answer that gives us 340 when X is 4. Well, choice A, 4 times 60, is going to be 240 plus 100 is indeed 340. If we did 60 times 4 plus 220, we're over. If we did 80 times 4, we get 320, not 340. If we did 80 times 4 plus 220, we'd be over again. And this is how you can avoid making an unintentional algebraic mistake. Just model this silly thing at the end of the section as the seconds tick away. And especially understanding that on your exam, unless you have accommodations, you're not going to have the time and a half that I allowed myself here. When we click next, we do have an opportunity to go review any questions we may have had issues with, but we'll then click next one more time. The module will be over. And once you're done with the Bluebook exam, do recognize that you're going to have to go back to the website to view everything and see your scores. So you have to go to that mypractice.cb.org to get your results. But hopefully looking at this harder math section practice set, and we'll ignore that little survey, of course there's always a survey, helps you as you get ready for your official test day, whenever it may be.